today is inverse functions and derivatives. So remember, if a function g is the inverse function of the function f, then, or I know it's a function if f of g of x is equal to x, or g of f of x is equal to x. So when I compose the functions, they equal the input x. So if g is the inverse of f, then f is the inverse of g. Okay, and then remember that we denote an inverse by writing f inverse. All right, so a function does not have to have an inverse, but if it does, then the inverse is a unique function. Okay, and if a function has an inverse, then the inverse can be found by switching the x and the y and then solving for y. Okay, so let's practice. So we're going to find the inverse of f of x is equal to 2x cubed minus 1 and verify that the inverses are a function, or that they are inverses using composition. So first, to find the inverse, we switch x and y. So we have x is equal to 2y cubed minus 1, solve for y. We get x plus 1 is equal to 2y cubed. We divide by 2, and then we take the cube root. So I have the cube root of x plus 1 over 2 is equal to y, or f inverse of x is equal to the cube root of x plus 1 over 2, or x plus 1 over 2 to the 1/3 power. All right, so verifying using composition. So I'm going to use f of f inverse of x, and that should equal x. Okay, so I'm going to start with f, and I'm going to substitute in x plus 1 over 2 to the 1/3 power. And so we're going to substitute that into 2 times x plus 1 over 2 to the 1/3 power minus 1. And, oh, and I forgot to cube my x value. So my 1/3 and my cube cancel. The 2's and the 2's cancel. So I get x plus 1 minus 1 gives me x. All right, verified. Woohoo! When I compose the functions, I get x. All right, remember that if a function passes the horizontal line test, then the inverse is a function. So I got this function x cubed plus 1 minus x cubed plus x minus 1. I'm going to apply the horizontal line test. Do any horizontal lines cross the function at more than one value? Nope. So this function passes the horizontal line test. Passes the horizontal line test. So the inverse is a function. Okay, this guy, x cubed minus 1 minus x minus 1. Ruh-roh. We didn't pass the horizontal line test. At this y value, I have multiple x values. So does not pass the horizontal line test. So inverse is not a function. If I want, what I could do is restrict the domain. So I could restrict the domain from, let's say, when x is greater than 1, and then all of this blue part would not exist, and then that graph would pass the horizontal line. Oh, maybe it wouldn't. We could do x is greater than 2. Okay, and then anything beyond this point, so anything up here would pass the horizontal line test. Okay, and then the function would be, the inverse would be a function, but you would have to restrict the domain to get a function. Okay, so some features of functions and their inverses are that if f is continuous on the domain, so if f is continuous, then guess what? F inverse is also continuous. Okay, if f is increasing, like this blue f right here is increasing, then guess what? F inverse also increases over the entire domain. If the function decreases over the entire domain, its inverse will decrease over the entire domain. If the function is differentiable on an interval containing c and c prime does not equal 0, then f inverse is also differentiable. All right. And then if f contains the point AB, then f inverse would contain the point BA. And the graph of f and f inverse are reflections over the line y is equal to x. Okay, up next. Now we're going to talk about derivatives of inverse functions. And so we're going to let f be a function that is differentiable on the interval. If f has an inverse of g, then g is differentiable at any x value, which f prime of g does not equal to x. So we know that g prime of x is equal to g prime of x is equal to 1 over f prime of g of x. This looks really bad. I'm going to show you a quick way to do this, okay? So first I'm going to show you that this actually works, okay? So if I have the derivative d dx of f of g of x, and I'm going to take, and we know that's supposed to equal x. So I'm going to take the derivative of this whole equation. So the derivative of the left side is chain rule. F prime inside stays the same times g prime of x. The derivative of x is 1. And then so to isolate g, just divide, g prime, I'm going to get 1 over f prime of g of x. Okay, so if I start with my function, I know that I'm supposed to take the derivative of each side. Again, this looks really bad, but what this says is that the derivative of f prime of x at a comma b is the reciprocal of the derivative of f of x at b comma a. Okay, so I'll show you again how this works. So let's let f of x equal 2x plus 5, and we want to find f inverse, the derivative of f inverse of 9. So f inverse prime of 9. F inverse prime of 9. Okay, and next up, I like to make a chart. So I'm going to make two charts, one for f inverse, and then I also am going to find the slope, or f prime, the slope, okay, and f inverse prime. Okay, so if I'm starting with f, I want to find f inverse of 9. So that means that the input is 9. That means that the output of the original would be 9, right? This is my B and my A and my A and my B, okay? So I can find my coordinating x value by plugging that into my function. So f of x equals, when is f of x going to equal 9? So 9 is equal to 2x plus 5. I'll subtract 5. Get 4 is equal to 2x, divide by 2. I get x is equal to 2. So when x is equal to 2, then the inverse has an ordered pair of 9, comma 2. Okay, so the next thing to do is to find the derivative. So I'm going to find the derivative. So step 1, finding the x. Step 2, we're going to find the derivative of f prime of x, since I have the function. So the derivative is 2, and then the derivative at x equals 2 would still be 2. So the derivative when x is equal to 2 is 2. We can say the slope equals m equals. Okay, so to find the derivative of the inverse of f, we just take the reciprocal of x is equal to 2. So whatever the output is of the inverse, we're going to find the derivative of the function. So the derivative was 2. The reciprocal of that would be 1/2. And that is it. So again, if we look back at our rule, we know that f inverse prime is equal to 1 over f prime of f inverse, or g, f inverse of x. Our x was 9, sorry, so this would be 1 over f prime of f inverse of 9. So I'm like, oh, f inverse of 9 was 2, so I'm taking the derivative of when the original function is equal to 2. Okay, and then you have to reciprocate it. So the quick way to do this is I fill out this little table, I get the derivative when x is at the original x, and then I take the reciprocal. Okay, let's do another one. All right, so this time we're going to find g inverse prime of 3. So again, I'm going to build my little table because this is how I save myself. Okay, g prime, and then I have x, g inverse, and g inverse prime. Okay, it says we want to find the derivative of g inverse when x is equal to 3. So here's my starting value at x is equal to 3. Remember, we switch the order, so the input to the inverse becomes the output of the original. So we can say I'm going to find g of x is equal to 3. So I get 3 is equal to 1/4 x cubed plus x minus 1. And I subtract 3. I am going to use polysmelt to find the 0 on my calculator, since it's a polynomial, or you can graph this on your calculator and find the zeros from the graph. Okay, so I get x is equal to 2. So when x is equal to 2, then I get an output of 3. So then I need to find the derivative of g prime of 2. So first let's find g prime of x. That gives me 3/4 x squared plus 1. And g prime of 2 would be 3/4 times 2 squared plus 1, which is going to give me 4. Okay, so next up, I guess I can fill in the 2 here. I just take the reciprocal of this, which is 1/4. So g inverse prime of 3 is equal to 1/4. So the derivative of the inverse at x equals 3 is 1/4. Okie doke. Last one. So I'm given a bunch of stuff. I have f prime, f inverse of x. And I want to find f inverse prime of 6. Again, I'm going to make my chart. This is like, again, how I save myself. Okay, So we're starting with, let's see, I have F inverse prime, 6 is the input, so that becomes the output to the original. So when does F have an output of 6? So I'm like, F has an output of 6 at X is equal to 2, okay? So that means the output to the inverse is 2. And then I need to look, okay, what is F prime of 2? F prime of 2 would be 4, okay? And then I can get my F inverse prime of 6, okay, because I'm looking at the original here. 6 is the reciprocal of F prime at X equals 2. So 1/4. So 1/4 too. And we done. So F inverse prime of 6 is equal to 1/4.